the important thing is this part right here. Recall that when you assume the null hypothesis is true, and we're going to attest the null hypothesis, no matter which way it ends up to be, that's the one we test, the null hypothesis. So if you want your things to have certain ways to say it, that's what you're going to worry about. And I printed out a couple of these sheets because we're going to be using these. Every time we do this. They're the same one. Hopefully, can you guys see it over there? Oh, just over here for that. Maybe not. Okay, so that you can see it. All right. So we're going to test your p-val. Your p-val, even though we call it a p-val, is a probability value. It is probability is the area under your curve. And first, we learned how to find the z-scores. We learned how to find the areas. And then we did a unit on probability. Probability is still the area under your curve, hence the name probability value. So we're still looking for area under your curve, and we're saying this. I'm going to tell you what the smallest error that I'm going to allow. If it's smaller than that, smaller or equal to that, it's very unusual. I don't want something that's very, very unusual. So I'm going to reject it. Reject the H out. And then we're going to see how we claim these from there. So there's two ways to do this. And when we test your p-val, we're either going to reject the H out, or we're going to fail to reject the H out. P-val tests the level of significance. So we're going to find your p-val, which we're going to be finding pretty soon, and we're going to test it against a level of significance. The level of significance is what the problem tells us. Like they told us 95% confident, they will tell us at a level of significance of 0.05, or a level of significance of 0.01, or a level of significance of 0.10. These are the ones we use. So if our value under the curve is smaller than that, then we're going to reject H0, regardless of what H0 says. So for instance, we get to testing. So I want you to watch the way we test. So for a given problem, they already worked out the z-scores. They found all the information. They found that the area under the curve is this. This comes off table 4. This is your area under the curve. We call it your p-val. They found your p-val to be this. They want to know, what is your decision if the level of significance is 0.05? Write this on your note page. I want you to test like this. P-val. Level of significance. Just write one down so you see it. You're going to put your p-val over here. You're going to put your level of significance over here. Now, you have decimals. You're going to fill in zeros to get as many places as that one has. So that has 4 places. I'm going to fill in 2 zeros. Now, when I compare my numbers, I'm just going to compare them without the decimal. Which is smaller or larger? 237 compared to 500. 237 is less than or greater than 500? Less than. So I'm going to do this. The less than gets the equal sign. Now, I look at my decision chart, and I say, when my p-val is less than or equal to my level of significance, my decision, this is my decision, write this down, reject H0. I don't know what it is right now, I'm just testing a p-val. So when you test your p-val, you're going to put it in that order, you're going to put as many places of zeros there, and you're going to test the numbers. Then, you're going to look at this part, and you're going to make a decision. So now, they say, okay, test it against a level of significance of 0.01. So I do the same thing. P-val to level of significance. My p-val from my problem was this. My level of significance is this. I put as many zeros as there are places over here because they both have decimals. Now I compare the number. 237 greater than 100. Agree? This way you don't have to look at the decimal plates when you get to this part. Greater than. So I come here. If my p-val is greater than my level of significance, this is my decision. I say decision. Fail to reject H0. Okay? That's all there is in testing. We're working our way to get to a full one. So I want you to try these two. Try these two. I want to know what your decision is. Try these. Here you both have to be 63. Or somewhere over there. 63, 64. Haley, wake up. Gotta try these. This is important. You're going to do all this work on problems. Come down to this part. And you try to have to test it. The most important part is giving your decision to somebody. Because your boss wants you to test something. He doesn't know what your p-val is. He doesn't know what your null hypothesis is. From that statement, we're going to be able to interpret the results. Should have wrote these a little bigger, huh? Can you guys see the charts from back there? I gave you the sheet in your notebook too. Because you're going to live with that sheet. So again, set it up this way. Don't set it up backwards. So they did all this work and they found out this was your p-val. My p-val goes over here. My level of significance goes over here. This is the smallest error that we're going to allow. We don't want anything more unusual than that. It's the extreme or the more than extreme. So now, it's hard for me to tell you who's larger. Fill this with zeros. Drop the decimal when you compare. So 745 is greater than or less than 500? Greater than. So I look at my chart. When my p-val is greater than my level of significance, what is my decision? And you need to say, fail to reject this whole thing, HO. If you don't say HO, you don't know what you're rejecting. It could be HA, it could be the plane, it could be anything. So you need to be able to say that. This guy, p-val. Where's this one? Fill in the zeros. 745 compared to 1,000. Less than or greater than? Less than. The less than gets the less than or equal to. So what's your decision? Reject HO. Everybody good so far? We're kind of giving you one step at a time. Now we're going to go through, well, where did that p-val come from? I kind of don't like a backwards approach, but I'm going with the book on this. So now we get to, okay, you know how to test it. Where did that p-val come from? Well, p-val came from under your curve. And what curve do we use? Whatever our HA says, wherever the arrow points off of HA. That's why it's important that you're able to make this plain. For a left tail test, it's going to say this. HA, for instance, it's always the HA. We'll say U is less than something, 10. This is a left tail test. A right tail test, I look at my HA. U is greater than 10. A right tail test. This is where my p-valve comes from. This comes off of table 4. My two-tail test says HA not equal to 10. I have two possible tails here. Okay, this is what we're doing with this. Stay with me, because hopefully before we leave, we'll do one entire problem together. Find the p-valve for a left-tailed hypothesis test with a test statistic. In other words, they got this from your z-score formula. They already worked that all out, and they got a z-score answer. So now, we know where your z-score is. I need to find my p-valve, taking a step backwards. I'm a left-tail test. Start like this. When we do the critical values, I like it better because we actually say reject, fail to reject, right on our breath. But this one works a little bit differently. So, don't I find negative 2.23 on the left-hand side of the 0? Wouldn't it be right here, where my left-tail test is? How do I find my p-valve now? How do I find my p-valve? If I gave you a z-score, how would you find the area under the curve? Table 4. Thank you. So let's go look at table 4. Where could it be here? Look up table 4. Look up negative 2.23. It's in the back of your book. I think it's like A16, somewhere over there.
Yeah,
A16, thank you. I'll xerox another table 4 for you guys. I just find it easier. I'm hoping it's easier like when you find it in your notebooks. So when I look up the area to the left, all I have to do is look up that number and give me the 4 position area. 0.129. This is my p-valve. This is my area under the curve. Probability value, the area under the curve. So now, I need to test. Here's my test. P-valve to my level of significance. If my p-valve is 0.0129 and my level of significance is 0.01, line up those things, put 2 more zeros in there. Just get the zeros down here. Now, compare the numbers. 129, less than or greater than 100? Greater than. So what's my decision? When it's greater than, go to your chart. When it's greater than your level of significance, fail to reject H0. I tested the HA. That's what gave me the tail. But my decision is based on my HL. Does that make sense? Okay. I'm jumping to example 3, a two-tail test. A two-tail test works a little bit differently. Find the probability value for a two-tailed hypothesis test with the test statistic of this. This is a two-tailed test. And how do I know that? Because my HA said something not equal to something. So when my HA says not equal, I have a two-tailed test. So if they gave me this as 2.14, what is this z-score over here? Good. All the things we learned apply. Two tails means you just got 2 chances to get this right. You have double the probability. So if I find this area, this is the same as this area, isn't it? So on the two-tailed test, I'm going to look up this area. I'm going to look it up in my table. It's 0.0162. And now, because it's also 0.0162 over here, I can add those together, or just say 0.0162 times 2. I have twice the area to get that. So I get 0.0324. That's my p-val. I'm going to test my p-val against my level of significance. My p-val is 0.0324. My level of significance, 0.05. I fill it with zeros. Is 324 less than or greater than 500? Less than. This is my less than or equal to. So what's my decision? Good. Everybody good so far? We're going to put this all together. You ready? We're going to put it all together. Now, a right tail test. Just hang on for 1 second. If I did a right tail test, and I looked up this p-val, say my test statistic was 2 point, let's use 2.14, since we know what it is. I need this little area under here. When you look up 2.14, remember you get the area to the left. And this is a very small area, isn't it? It's less than 50%. So what do I have to do when I look that up? Minus it from 1. Or I can use the concept of symmetry and look up the negative number. I will still get that little value. That's the only thing. We're going back to our table 4. Okay. On your notes, go to this page where I give you this little chart. We're going to use your beloved z-score formula. And every time we use a sample, we have to take your population standard deviation and divide it by the square root of n. This is your central limits now I'm coming back out. So we remember that. We also need to know that it's normally distributed or n is greater than or equal to 30. Your problem has to state that somewhere. So we'll find that in there too. So these are the steps we go through. This is important. You're going to verify that you know the population standard deviation and that either we're normally distributed or n is greater than or equal to 30. Remember, you're testing a claim made against the population with your sample. You're going to state the claim. You're going to identify the HO, the HA. We're going to pull out our level of significance. It's either going to be 0.01, 0.05, 0.10. We're going to test it. We're going to find your z-score. We're going to graph this with a tail. We're going to find your p-val right now. We're going to test it. We're going to make a decision. And then we're going to go to this chart right here. And we're going to interpret your decision. Okay? All right. I need everybody awake for this. This is the big one. Who would like to read this for me? I'm running out of voice. Sarah, thank you.
In auto racing, a pit stop is where a racing vehicle stops for new tires, fuel, repairs, and other mechanical adjustments. The efficiency of a pit crew that makes these adjustments can affect the outcome of a race. A pit crew claims that its mean pit stop time for 4 new tires and fuel is less than 13 seconds. A random sample of 32 pit stop times have a sample mean of 12.9 seconds. Assume the population standard deviation is 0.19 seconds. Is there enough evidence to support the claim at standard deviation of 0.01 using p-value?
Level of significance, but that was very good. Good. Now, it's got a lot of information in here. First thing we do do we know the population standard deviation? Yes. Is n greater than or equal to 30, or did they tell us it's normally distributed? Where is your n? 32. Remember, somebody made a claim against the population. We're testing it with our sample. What's their claim? This one's nice because it says they claim. It doesn't always say they claim. Sometimes we have to go back down here, and I'm going to show you how this lines up. A pit crew claims. Here comes the claim. So I'm going to start like this. Claim. The mean pit stop time. What parameter do I use for mean? New. Good. Mean pit stop time for 4 tires and fuel is less than 13 seconds. Less than 13 seconds. This is the claim. Is this the HA or the HO? HA. Because why? No equal sign. Now, what's the HO? Now, here's a good way to check this. At the end, they use the word support. You support this claim. He's making the claim that it's less than 13 seconds. They certainly don't want to say greater than 13 seconds, right? I want to support that claim. I'm kind of agreeing there. I'm going to test all these things and see if I can support what he just said. Now, look at this chart. What one uses the word support? The HO or the HA? HA. So, claim is HA. Is my claim my HA? I'm on track because I'm supporting my claim. So my claim has to have the word support. It has to be an HA. Is my claim HA? Now, from here, I'm going to make a sketch. I'm going to see what tail this is. My tail follows my HA. I would write this whole thing down so that you understand this one. So am I a right tail or a left tail? Left, because that points to which direction? My HA points to the left. I'm a left tail. I need that Z-score so I could find that p-value. So this claim is made about the population of this auto racing pit crew thing. I'm testing it with my sample. My sample has 32 cars or things that I tested, and I have a mean stopping time of 12.9 seconds. And because this is the mean one, I need to know what my population standard deviation was. So I keep reading, and I see my population standard deviation is 0.19 seconds. Now, this is not my sample standard deviation. I have to adjust my sample standard deviation like this. It's going to shrink it down a little bit. I can put that in my formula. I can do it out if I feel like it. It comes to 0.03. But I'll put it in our formula as well. So now, Z-score. We need to find, this is called the test statistic. These are all the pieces. So we know that that Z-score is going to be negative, right? So the mean stop time was 12.9 minus the population mean, which comes from this statement, because where your mu is, over the population standard deviation divided by the square root of n. It's a lot to get put all together. That's That's why we had to go through these background things. So I put this in my calculator, my trusty calculator, and I get my z is equal to negative 2.98. That's this guy right here. I'm almost there. Almost there. I need a p-val. Where do I get my p-val from? Table 4. I look up negative 2.98. Do I want the area to the left or to the right? To the left. I need it to match my graph. So I look up the area to the left, and I get 0.0014. Now, after all this work, I'm ready to test this claim. P-val, level of significance. Here's my level of significance right here. My p-val that we just found from our test statistic is 0.0014. My level of significance, 0.01. So I am going to fill this with zeros. Is 14 greater than or less than 100? Less than. Less than, equal to. So what is my decision? Good. Reject H0. Now, we're only part of the way done. The most important part is this next part. So I go to this table here, this chart. I say, my claim is my HA. Agree? I got to use one of these support words or no support words. I go to my decision, reject HO. Now let's think this out a second. This was my HO, that it was greater than or equal to 13. I rejected this. So am I agreeing with what the pit crew says? Yes, I'm agreeing with him. I'm rejecting this piece right here. We set it up so that we're going to support his claim. We agree with him. So now, when we come to here, we reject HO. This is how you interpret this. And this is what you need to write. There is enough evidence to support the claim that the mean pit stop time is less than 13 seconds. That's your final answer to somebody. They're like, what do you think? You say, there is enough evidence to support the pit crew claim that the mean stop time, pit stop time, is less than 13 seconds. I've got to use this word support. I have to replace my claim with this claim. So I'm going to say, there is enough evidence to support the pit crew claim that the mean pit stop time is less than 13 seconds. This is what I did all this work for. And this interpretation is even more critical than about the confidence level intervals that most of you still can't interpret. So this is why we had to go through all those crazy things. We had to set up your claim. You have to know which scale to use. You have to know how to interpret your chart. And we could make errors. We can make errors in this. We could say that it's not. We could not reject something. Maybe we didn't reject it, and we didn't have enough evidence to support it. But maybe, in fact, they did stop at less than 13 seconds. Your error comes from your sampling error. So you've got to make sure your samples are good. And if you're doing this to support something or go against something, you're going to definitely do more than one sample. Does this make sense? Okay. We're going to squeeze in one more. Ready? Any questions at all? This is major. This is major. How do I know where to start? Always start at your claim. From your claim, You have an HA, draw a graph. From your graph, shade it in. I gotta find a p-value. How do I find the area under the curve? I use a z-score formula. Once I get that area under the curve, I look at my chart, I gotta test it. Once I test it and make a decision, I gotta interpret it. The ones I put in your notes, the steps to go through, those are the steps. Once you get the hang of this, it's not so scary. Is this also less? Hang on. Okay, this is a different one. Okay, this is a good one. This is a greater than. I just didn't want to do another less than. Okay, homeowners claim. Here's my claim. Homeowners claim. Homeowners claim that the mean speed, the mean uses which parameter? U. That the mean speed of automobiles traveling on their street is greater than, here's my math statement, is greater than the speed limit of 35 miles per hour. So I need to write my claim in terms of mu. It's greater than. How do I write this? Greater than 35. Good. No equal to, right? Is that the HO or the HA? HA. Now, write its complement. The mean less than or equal to 35. I did a sampling here. I sampled 100 autos. So since my N is greater than 30, do they have to tell me this is normally distributed? N has to be greater than or equal to 30, or they got to tell me. In this case, I'm okay to go with it. And my mean came out to be 36. My population standard deviation, this should say population standard deviation, is 4 miles. Is there enough evidence to support? Oh, it used the word support. So when I look at my word support, what should my claim be? Is my claim HA? So that part's good. Now, next, I look at where my sketch has to be. Which one do I look at for my shading? Right, because I look at the HA. Shading right. And I say, okay, so you shaded right. I need this p-val up here, but I need to find this z-score. That's what I have to do next. It kind of flows once you get used to this. So the z. Okay, so we take your sample. You're testing your sample against what we're given. So my sample is 36 minus 35. Oh, does that give me a positive? Does that put me on the right side? Over this guy. Make sure you change your standard deviation, because your standard deviation for your sample is this, 0.4. Okay? And you could just do it right in your equation. Use your alpha key. All right. So I find my z-score, 3.5. Good. Does that make sense to me? Yes. Find me the area under the curve. This is to the right. Your table 4 gives you area to the left. Do I expect this to be greater than 50% or more than 50%? I'm sorry. Greater than 50% or less than 50%? This little area. Less than. So when I look it up, what do I find? It's a pretty large number, isn't it? So what do I have to do? Subtract it from 1. So I have to take this guy and subtract it from 1. Because this is far less than 50% here. That's why your sketches are very, very helpful. So my p-val in this case is 0.0062. Now, I did all this work. I can test this. Here's my test. This guy is called my test statistic. And remember, statistics come from your samples. Parameters come from your population. I took my sample, I tested it, I came up with a test statistic. I'm testing now my p-val with my level of significance. Here's my level of significance. Here's my p-val. I'm going to fill those with zeros. Is 62 less than 500 or greater than 500? Less than. So I'm going to use the less than or equal to. So what is my decision? Good. Reject HO. This is my decision. Always write your decision first. Now, come back to this chart. Your claim is HA. You rejected HO. So let's see in reality what this means. HO was that it was less than 35, less than or equal to. My claim is that it's greater than 35. If I reject this guy right here, do I agree with my claim? Did I support the claim? Yeah, it is good. My claim is good. But I can't say, yeah, my claim is good. I can't say, yeah, I'm right, it's good, it's cool. I have to say, there is enough evidence to support the claim that the mean speed on their road is greater than 35 miles per hour. That's my final decision here, how I interpret this. There is enough evidence, and it's probably even better if you say enough evidence at a level of significance of 0.05 to support the claim, support the homeowner's claim that the mean speed, this is probably the longest part, is greater than 35 miles per hour. Yeah, with that 4 in there, it probably wouldn't have been so. You would have been forced to be outside that area, but your standard deviation shrunk a lot because of your sample size. Can you kind of get the flow of this? It's difficult for you.